Greetings, math friends. Let's see if we can prove that the limit as h approaches 0 of cosine of h minus 1 divided by h is 0. We're going to start with a little bit of geometry. We're going to start with this triangle inside an arc, which is the first quadrant piece of the unit circle. So this distance here, this radius, is going to be 1. We've got this triangle in here where the base of this inner triangle is cosine, the height of the inner triangle is sine, and we have this sector here, the sector ACE, falls in between this larger triangle that's created out here. And we're going to kind of do a bit of a squeeze here. So the area of the small triangle, area of triangle ACB, is going to be less than this sector. And we want the sector, which is ACE. And that's going to be less than this larger triangle DCE. All right, so the area in here is smaller than the area here, which is smaller than the area there. And let's fill in some things. We know that the area for a triangle is 1/2 base times height. So this is going to be 1/2. The base of this is cosine, and the height is sine. The area for the sector is going to be 1/2 the radius squared times theta, and that is going to be less than this triangle out here, which is 1/2 of the base again. So the base of this is cosine theta plus this segment BE. And then that is multiplied by this height, which is the tangent of theta. Something to note here that the distance between C and E here is the radius 1. So this value that we've included, cosine plus the segment BE, this is all equal to 1. So we really have 1/2 times 1 times tangent here. So that's a nice simplification. In my diagram, it kind of looks like DE and CE might be equal to each other, that this is an isosceles triangle. We don't want to believe the diagram on that. It's really that this distance is 1 and that this distance here is going to be the tangent of theta. Cleaning this up a little bit, we have this more compact form as we multiply by these ones that are in here. We can now multiply the entire thing by 2 to clean out these fractions. So we have that the cosine of theta times the sine of theta is less than the angle theta, which is less than the tangent of theta. And the next thing that we're going to do is divide by sine to get cosine by itself. So we will have cosine of theta is less than theta divided by sine of theta. And that's going to be less than, tangent is sine divided by cosine. So if we divide by sine here, we get 1 over cosine of theta here. We're going to take the reciprocal of each of these terms here. We will have 1 over cosine theta, reverse the inequality, sine theta over theta, reversing the inequality. We have cosine of theta. If we look at the limit as theta approaches 0, for each of these, we'll have 1 over 1 here. This we will, for now, leave as is. And then we will see that this also goes to 1. So by the squeeze theorem, we see that this is going to be 1. We're going to have to make use of this to actually prove the original thing that we are trying to prove. So we're going to reset just a little bit, keeping the new lemma that we have, that the limit as theta approaches 0 of the sine of theta divided by theta is 1. Having reset, we're looking at this. We have this lemma. It'll come into play here. First of all, we're going to multiply the numerator and denominator by the algebraic conjugate. Since we're multiplying the top and the bottom here by the same, this is effectively multiplying this by 1, so it's an equivalent fraction. It has the same magnitude. This is going to give us the cosine squared of h minus 1. And then on the bottom here, we are going to have h times cosine of h plus 1. All right. I'm going to pull the negative out of this. We're continuing to do the limit here. All right, pulling the negative out, we can see that this should be recognizable as a trig identity that we should know. This is really sine squared. Now we're going to split this into two separate fractions. All right, so if we multiply these two fractions back together, we're going to get this fraction here. Now we're going to take the limit of these independently. The product of limits is equal to the limit of the product. All right, this very first piece here, this factor, is where our lemma comes into play. This is going to go to 1. And then we look as sine goes to 0, this is 0. As cosine goes to 0, this is 1. So you get 0 over 2, which is just 0. So we have 1 times 0 is 0. So what we end up with is that the limit here is going to 0. And that concludes our proof. Hopefully this has added a little insight in why this limit is going to 0 and some of the things that go into proving that. Cheerful calculations.